Hello, everyone. Welcome to our first Sunday live stream. We're going to be talking a lot today with two different people. Steve, you know him as Teeth of the Lamb on YouTube, and a new guest. His name is Ron. He's from Florida, and we're going to be talking a lot, I think, about the moon and about Venus and about different things like that. But what I want to announce right away here is that since this is the first time we're doing this and we have a lot of slide presentation to show you, we're working out the kinks. This is the first time that I've ever had other people share this StreamYard software where they actually are trying to use their screen to share their information and things like that. So we're trying to get those kinks worked out. So as we do that, for those watching this on the replay, at 5 minutes, 5 minutes into this, that's our goal right now for getting into this. And we're going to see some unique uh, same time photographs of the moon from different places on the earth. Same thing, we're going to talk about Venus, and I'll be repeating some of this again, but I'm going to play probably devil's advocate where I can. I hate that term, but I don't know what else to use where everybody else would recognize immediately what I'm talking about. And so I'm going to try to think like the other side does, except without the rudeness, and try to come up with arguments and things like that against what maybe they're saying. It's not to be mean or anything like that. It's just I want to anticipate the comment section in advance. And there's nothing wrong with that. Like I said, maybe it'll teach some people how to actually do it without being ignorant and rude and things like that. See, I was going to say, we're going to have probably a couple of trolls here. See, Dramatic Jive, Flat Earth, you people are so thick. See, Dramatic, we don't take crap like that. There's no reason to treat other human beings like that. So from that, you just can't, you're not going to be seen. I'll give you one more shot. People in the moderators that are here, you see stuff like that, I would say give them one warning. Other than that, goodbye. There's just no need to treat other human beings like that, especially when we're at a time in our lives where the governments around the world are treating us like we're not human beings. We're being treated like cattle with our rights just stripped away from us. Hello, Robin. Hello, Chase. Hello, Rethink. You're here on time. You got the announcement, huh? And what we're going to do here is have questions from you guys as well. So we're still waiting on Steve. You got 2 minutes, Steve, if you can hear me. Just kidding. Take your time. Steve's having a camera issue. His computer was showing the wrong camera. It was showing his laptop camera, and he needs another camera to be shown. Sleeping Warrior. This is my real account, but I have active imitation accounts pretending to me. Give me a wrench so you know it's me. How do I know you're not the pretend one? You know what? This brings up too much of a problem, Sleeping Warrior. I'm not going to do it. Sorry. You'll have to contact me privately. You know how to do that, and let me know that's your icon. Tony, while we're waiting here, Tony says you were right about the video last month by Jerry Day talking about COVID-19 and the banks. I had 3 links to on different channels, and all 3 links have been removed. Luckily, I downloaded it. Yeah, that's another thing. Freedom of speech has been going a while, and with all the censorship and things like that, and yet nothing is being done about it, is it? So we're almost 5 minutes into this. And looks like Steve is not ready yet. So let's go to 6 minutes. So we're going to go 1 more minute here. Hopefully everything will be good then. Darcy, thank you about agreeing about we're being treated horribly. Robin, you're finishing up vacuuming. Once you're finishing, come and do mine. I actually have to get Sleeping Warrior. Let's see. I can verify that since we're waiting another minute. Uh-oh. For my security, I've been signed out of, oh no, it's asking for a password. Hopefully this is it. Can't believe this. Oh, wait a minute. I think maybe I know what it is. And here we go. I'm actually in. All right, very good. That was the way to do it. I didn't want to say through Skype, but let's see. Why isn't it letting me give you a wrench? Let me do this first. Hey, can someone give Sleeping Warrior a wrench? I don't know why I can't, but it won't allow me. Let me check somebody else out, see if it'll let me. Thank you. Yes, it was nice to get a haircut. And I had to put on a stupid mask to go in there. Can you believe that? They gave me one because I didn't have one. I refused to have one myself. So now I have theirs. It was a piece of crap. It was hello, Mike. Mike Balls here. Good to have you. We are having big time problems with Steve's connecting. Hey, if you can hear me, Steve, we don't necessarily have to have your camera going. Just if you can just share your computer, that will work. Hey, Mike, can you give Sleeping Warrior a wrench? I cannot give people a wrench. Let me see something here. Yeah, you know what? I'm gonna have to. I'd have to see it on the actual YouTube channel. All right, let me see if I can hear Steve. It says no devices connected. Okay, let me ask. Let's welcome in Ron. This is it Hagberg? Ron Hagberg?
Yep.
He's out of Florida, and because of that, Steve is in Oregon, and they've had some interesting work with their cameras where one is taking a picture of the moon at the exact same time as the other, and they've noticed some interesting things. As far as I know, we still don't have any pictures, unless you know, Ron, if you would, Steve, would come across of anybody from south of the equator with pictures of Venus.
No, still
Waiting.
Yeah. I think it's getting winter time down there and the weather's kind of bad. So.
Yeah. Okay. Well, hopefully we can get that because I think there's not going to be any flip like we see with the moon.
Yeah. The only picture, it's hard to find. I try to Google search some pictures of Venus from in the southern hemisphere, and they're almost impossible to find. I don't know why. I found one from Australia from like 2008, but I can't compare that to what we're seeing now. But it was sideways from there in 2008. I don't know, what it would be, but.
Yeah. So what have you two really been talking about and getting into?
We've been trying to figure out this whole thing with the perspective, if perspective's causing the rotation of these objects, and we thought comparing the moon to Venus, would tell us something, because we shouldn't see, like, just between my pictures and Steve's pictures, of Venus, he's seen it at a different angle than I am. And, we're only 1,000 miles apart really from north to south. I mean, he's further out west, of course, but just our latitudes are only 1,000 miles apart from each other. And Venus is 23 million miles away. We shouldn't see that much deviation, to our locations on Earth.
No, I agree, and that's pretty amazing if you're seeing different angles. Yeah, from the supposed distance of Venus, that definitely shouldn't happen. It looks like Steve's here. Let's see if it can work.
Oh, there he is.
Hello, Steve.
Hello. How you doing?
There we go. Good. We're working out the little kinks, huh? First time doing this?
Yeah, this is all new to me.
I'm going to try something
But
here.
I got
Let's
it.
see. All right, we can do it that way. We can do it that way. And let me see if one of us is going to present how that works. We'll just have to wait and see. Have you figured out how to get this to present? Steve? Have you tried to share your screen?
I think it's, no, I think it's just like what Ron said down here at the bottom. You have a...
You see what says mute and then stop cam,
share
mic, share screen?
Yeah.
Yeah, if you click share screen, and if you have, I don't know what application you would have open to show your slides.
Let me find it here.
What'll happen is it'll show you whatever you have open, and if you don't have, if it doesn't show an open application, you have to actually flip to that tab. It's sort of like StreamYard know that it's active, and then you come back and click share screen again, and then it should show in the list under application or whatever you have it under, or your browser or whatever.
So application window, it looks like.
Right, and what'll happen is once you select it, you won't be able to see this screen anymore. You'll have to tab back to make sure it's showing okay. You don't have to. I can let you know if it is. But then you can talk us through whatever you want to talk us through.
Uh,
Oh, welcome again, Patricia.
well,
Now, if you don't want to do that, whatever, I have the video. We could do that.
Are you seeing anything yet?
No, not yet.
Okay.
But let me see. Let me put us.
So it's sharing a window.
And no matter how I click this, yeah, you're sharing your camera right now.
Oh, okay. Then I've got the wrong thing here. I just need to figure out how to pick the video.
Yeah, is it the same video that we're talking about? The YouTube video?
Yeah. Yeah.
Okay. Well, let me see if I can click on that. Let me share that and see how it goes. See if it's big enough. So let me share the screen. There it is. Now let me make it a little bit larger, if I can. Actually, let me just maximize it, see how that does.
Yeah.
Yeah, the problem is with this, I can't make it very large unless I take us off. Let me see. That makes it a little bit larger. So what part do you want me to go to? Where do you want me to go to first?
Well, why don't we start talking about Venus? What do you think?
Okay, sounds good. You want to just talk first, or you want to go to a special area of the video?
Let me see if I can figure this out here. Just one more moment.
Okay. Yeah, Venus is something interesting. Again, what they've been talking about, guys, is Venus should not be at different angles from anywhere on the Earth. It should be the same because it's supposedly what is it, 200 million miles away? And so a 1,000 mile or even wherever you are on the Earth, it should make no difference. If you can picture, the angle that you go out that many millions of miles coming back to us, it, there's no way on the Earth you could be at the North Pole or the South Pole and looking at it. You should have any kind of a difference because it's just not big enough of an angle difference. But what we haven't gotten yet is any pictures from anyone south. It doesn't have to be in Australia. It could be anywhere south of the equator. If you can send a picture of Venus to me, Rich at MrThriveAndSurvive.net, Rich at MrThriveAndSurvive.net. If anybody knows anybody that has pictures of Venus that shows the phase using the camera, you'll see when Steve pulls up these photographs, what we're talking about as far as showing the phase. We'd like to compare them. And evidently, Ron and Steve are getting different angles from Venus just from being from Florida to Oregon, which makes no sense.
Yeah, actually, if somebody had one from South America where we could see it in North America and South America at the same time, that would be probably even better.
Yeah, exactly. Yeah.
Pictures.
There was supposedly somebody was going to send something from Australia, but nothing yet. Do I mean the angle relative to the horizon? No, I mean the angle in the sky. It's like the moon angle when it's not full. What direction is the lit side facing? That's the angle we're talking about. You'll see once we get the pictures up.
I don't think I have them on here.
That's okay. Well,
that's not going to work very well for me.
Okay. Well, I will. You just tell me where to go in the video, and I'll go there. Sorry about this, guys. This is what happens the first time you do anything.
Sharing isn't working very well.
Yeah, I mean, I can see what you're sharing. You're still sharing the camera. But yeah, don't worry about it. I'll share it. Just let me know where. Maybe I can. You know what? Let me try something too. Trying to use Control Plus to make the screen bigger, and it's just making the it's making the text bigger, not the screen. So, do you want to just talk first? Or do you want me to go to a special place in the special place on the video, Steve?
Okay, if you go to timestamp 206.
Okay, get there. Well, I made this really big.
Yeah, you'll probably have to shrink it down.
Yeah. Alrighty, getting there. 206. And this is going to be the moon?
Venus.
Is this the second edition?
It should be on either one.
I've got the moon at 206.
Oh. This may not work out well if our 259. Try that.
Alrighty. Yeah, there we go. So just a second here. There we have it.
Try 3 instead of 2. Let's see what you got. Yeah. So what we've got is Venus doesn't seem to rotate at all. Like the moon, Venus seems to be a fixed stationary object. And these are different hours or different times that I've filmed, taken pictures of Venus. And then I have the theodolite that just gives the coordinates of where Venus is in the sky. But the unique thing is that Venus should be rotating. We get a rotation from Venus when we move locations on Earth, and that's what they say is the reason the moon rotates. But Venus doesn't move at all when you're in one location. But if you move from across the United States, or if you move mainly north and south, it'll appear to show a rotation. And we've only done that in 3 different places: the UK, Florida, and Oregon. So we wanted to get something from the southern hemisphere to see what it does there. But if we go to just a little bit further here, if you go to 303, we have the rotations.
Now, these all taken roughly the same time?
Roughly, yeah. different days, I think. But in each location in the UK, it's been static, and that was a picture from Dave Marsh. And then Oregon, that was mine. You can see a little bit of a rotation. The angle isn't quite the same. And then in Florida is Ron. He was pointing straight down. And then the one from New Zealand was a young man that didn't have a very good setup. He knew that, but he put his finger over. You can see it's facing off about 8 o'clock. But it's good enough. It gives us an idea that yeah, we are seeing a rotation between different locations. Now, the moon, if you're in one place, my angle has been the same for months now on Venus. But the moon rotates like a bandit every day. I mean, you get a quarter to a little bit more to 3/4 of a turn on the face of the moon. That's a problem when you start looking at that with because of the reason they say that we have a rotation is a thing they call field rotation. And that's where the moon, they say, gives an apparent rotation, and so do the constellations. They say that's because of the spin of the Earth, which would make it travel across the sky. But the reason it appears to rotate is because of the arch of the ball. So when you boil it right down, what really makes a rotation is the arch of the ball that you're living on. But when you really look at that and analyze it, you find out that's not possible. Because if you're tilted toward the moon, you would be making an arch or an arc. No, when you're tilted away from the moon, you'd be making an arch on a ball. So if you take a ball and tilt it backwards away from you, and you have a circle drawn around it, you're going to get a kind of an arc. And I have a picture of that, I think. Let's see if I can find it. You got to pardon me.
Before we take your time. Before we leave here, to me, this makes no sense. If it's 200 million miles plus away, how is someone in like your Oregon and the UK, your latitude is pretty much the same, and to me, it doesn't matter what your latitude is. We shouldn't see this, not from something 230 million miles away.
If you go to 353, I have a right there. This is just it'll help you understand. If the one on the left, you've got the ball tilted toward you, and so you'd make kind kind of a dipped trajectory across the face of the Earth. And the one on the right is when the ball's tipped away from you. And you see, that arc there is what it takes to make the moon rotate in a clockwise rotation. But the problem is that the Earth is tilted, so they say. And this becomes a real problem because half the time, if the moon circles the Earth in let's say 27 days, half the time you're going to be rotating around the arc side where it's tilted toward you or away from you, and then you're going to be in a dip, and what's going to happen is the moon is going to rotate the opposite way, and we never see that. We get a little tick backwards in it that for about 20-30 minutes, and then it'll start rotating forward. But you never see a reverse, and the thing is, in the southern and northern hemisphere, it's the same problem. So you can't have an arc causing the moon to rotate and the stars, and then half the time being in a upside down arc or curve. Do you follow what I'm trying to say there?
Yeah, we see a consistent movement of everything throughout the year. There's never a change.
So why don't we see the moon rotate half the time backwards, counterclockwise? We don't. So there's a lot of problems with this moon rotation and the thing that they call field rotation.
Yeah, well, here's another thing we noticed is Steve says the first half of the night, his moon is constantly rotating, whereas here in the Phoenix area, the moon does no such rotation at all until it reaches zenith. It's absolutely still. That makes no sense.
No, not at all.
And we're both north of the moon, so they should do the same thing. And there should be a mirrored effect anyway. The first half should match the second half of the night. If you're gonna rotate the second half of the night, let's say 50 degrees or 120 degrees, whatever it is, you should get the exact, you should get half of that before, from the moonrise to zenith, you should get rotation, where we get zero. We get absolute zero here. And yet you say you get it, and this is during a full moon. You say you get rotation the first half of the night and the second half of the night. Is that correct?
I do. Sometimes there won't be much rotation in the morning, and sometimes there won't be much rotation in the afternoon. There's nothing consistent, and you got to think about perspective. Perspective will make things diminish in size. Perspective can give you a different angle of view, but I've never seen perspective make whatever I'm looking at rotate. You know what I mean?
Yeah.
And they're saying, of course, it's the curve of the Earth and the arc that you're making. But, we don't always go in an arc if you're on a tilted ball. And if you're going straight across, if you hold the ball straight up and down, you go straight across. There is no curve up or down. So, it just doesn't work out.
Yeah, I agree. Doesn't make sense to me.
And why we would get no rotation in your location, which it's probably a few hundred miles south of where I'm at. I'm not sure how far it would be, maybe 500 miles. Why I would get rotation and you not? Now, Ron has taken pictures in Florida, and his moon, when we take them at the same time, the Sea of Crisis is advanced further clockwise than mine, which is kind of strange.
Yeah, it should be the other way, I would think.
But
if anything, you've got a picture of that too, don't you?
Yeah, somewhere. What we think that is because the angle of view. But I think that we also have seen where we've taken pictures right when as the moon was setting. Just the other day, the full moon, it was 99.9% full, and Ron had his moon was advanced quite a bit more clockwise than mine, and that was probably moon rotation plus his angle of view. That's why he showed up further ahead.
Right.
Yeah, and I think that can only happen if the moon's close. I mean, we shouldn't be seeing that if it's 238,000 miles away.
No, I agree. So where you want to go next, Steve?
Let's see. Next time I'll be more prepared because I didn't realize how this all works.
No, it's okay. There's always a first time.
Yeah. But do you want to go back to Venus or not?
It's your call, your show.
Oh, let's stay on the moon. Here,
all right. You just let me know where to go.
If you go to timestamp 159, a real short little segment here that I have a video that somebody else had made, and it shows some photos they had taken of the moon that show the rotation we're talking about. 159, and can you play a video there? Yeah.
Yeah, I'm actually playing it now.
Perfect.
Are you seeing it play?
Yeah. Yeah.
Let me go back and start it again. There we go.
You see that round Sea of Crises along the right edge, how it's moving forward. And that's a good reference point. But you see the shadow and everything's moving.
Yeah, the shadow definitely moves with it.
Yep. But that is another problem. If you think about the sun and where it has to be and what angle of the Earth has to be at in order to get that angle, I don't see how you'd ever be in an angle that would cause that on the Earth. And it's kind of hard to explain how that would work. Sometimes it's pointing straight up. Now, where would the sun be then? And that's at night. I mean, if the light source is coming from the top, then and the sun has to be at right angles to the Earth. I mean, they say it doesn't move, and so for the shadow of the moon to be pointing straight up, you'd have to spin the Earth in some funny ways.
Yeah, there are definitely times to me it makes no sense whatsoever.
Well, I don't think you could put the Earth in the right position when you're spinning one direction, and you kind of know which direction that is. It's from east to west, or from west to east. This is the way it spins. It turns into a real mind twister, though. Let's see here.
And the last part of this is what I see after zenith. It rotates that fast, but none before zenith. None.
Yeah. All these different angles. If you go like to timestamp 128, the blue picture of the moon facing upward. Right there. See how that's angled? Now just think how you'd have to turn yourself on the Earth to get that angle. And if the sun would have to be right above it. Now, I don't know where the sun was on that particular picture, but you get that at night too. And that's not possible at night.
Yeah, that's got to be a waning moon. I don't know what that is. That's yeah, that's got to be
I'm not-
waning. Yeah, you do get that at night, don't you?
yeah, you get all these different angles. Another problem with these angles is if you go to timestamp 34 seconds. This is their little diagram that they make of how the shadows are created on the moon. And so you've got the sun on the right, the light source, it's fixed. Each of these moons is basically has to be in that position or a variation between the moon next to it. But each of these moons has to be in that orientation to the Earth to create that phase. If you're on the terminator line on the Earth, we know which direction that terminator line is. It's basically from north to south if you're on the edge of the Earth. So
Right.
the red dot there on the Earth, basically that's where I took the photo that's on the top. I took that photo on the terminator line as I was passing in just as the sun was setting. So tell me, how can you get that angle? You got to think. Gibbous moon on the. I've got the arrow pointing to it. How can you angle it that direction and still be on that moon? The shadow has to be exactly the same as the Earth. It can't be anything else. I mean, it's got to be vertical, just like that on the Earth, but it's not, because we're right on the terminator line, so the sun has to be at a direct right angle to the Earth, and it has to also be that for the moon. There's no way in their diagram that you can get the sun shining from the top, unless there's another light source. And I've often thought that there could be, because so many times we're looking away. The sun doesn't match the angle of the moon at all. Sometimes I see it set on the horizon. The sun will set, and the moon will be facing. The lighted side of the moon will be facing the complete opposite way. How does that work out? Light's pretty simple. So is shadows, and they just don't work out. So there's something else going on other than what we've been told.
Yeah, like maybe the moon is its own light source.
That's what God says it is. Enoch, if you believe in Enoch at all, I mean, but
I do.
That's the only reference that I know of that says that the moon gets like 15% of its light from the sun. So some of the shadows could be from the sun, but other than that, everything in the Bible says it produces its own light.
Man, another thing with that graphic there, even if you're on that terminator line, how far below the horizon would the full moon have to be? We should never, because the moon is supposed to be 180 degrees from the sun, just like in that diagram. But even if you're on the terminator line, the moon should still be far below the horizon. But yet we see, a 99+% full moon in the daytime quite often. We should never see that.
Yeah, no, I'm with you.
And I think it should be, probably 6 hours after sunset before the moon would even be visible above the horizon.
Yeah, you can't see over the curve of the Earth, and they've got the math for that, 8 inches per mile squared.
Yeah.
I mean, if you take 100 miles, which is just a little bit on that ball Earth, according to what they tell us, 100 miles, you got 1.25 miles of curvature. You know, that's a pretty big mound to be seeing over.
Yeah, another thing I noticed, they say the moon's constantly moving, takes 28 days to orbit the Earth or whatever, but they say the phases are constantly changing. Like, 99.8765, and they change about every hour. But during a lunar eclipse, the moon has stayed 100% full for over 12 hours on some of them, and that is impossible in the heliocentric model unless the sun and moon are both moving. I mean, if the moon is reflecting the sunlight, which I don't think it is either, but that just destroys their model. The full moon should not stay in that phase for 12 hours.
That's true. It's nearly impossible to get some of these angles, and you got to look at this graphic that they draw. This is set in stone. I mean, they've isolated themselves down to just 2 movements. Basically, the moon is a fixed object. When you see it in any of these locations around the Earth, it moves. The moon would, they say, that these are all numbers that they give us, so that's why I'm using them. I don't believe most of the stuff they tell us. But the moon moves 0.5 degree, 0.5 degrees per hour. And that's something we can actually test for ourselves, and it seems to work out. Actually, the moon moves faster and slower, but it always works out by the end of the day to be about 0.5 degrees when you divide it out by the hours. But it's impossible in these locations to get these angles of the light source, because the sun is fixed, the moon is fixed. So now there's two motions you have: the spin of the Earth and the tilt of the Earth. That's the only thing you can change what you see, and it's not sufficient to be able to create these angles on the moon that we see. Even if you're going in an arc, you still can't get them. It's not enough of an arc, and then half the time you're going in a dip. So you got to have this one case where they say you can't have it both ways. You've got to have it both ways if you're talking about the field rotation.
Yeah, that's an excellent point, where half the year the arc would have to be reversed, wouldn't it?
No,
never even thought of it that way.
Half the month, Richard, because remember, the seasons change as you spin around the sun. That takes a year, but the Earth is constantly tilted. So as the moon traverses around the Earth, it takes 27 days. So half of the month it would be circling around, either tilted toward it or away from it. And they say, well, it goes in an elliptical orbit, and it's tilted. But the thing is, the moon only tilts a certain degree, because you only see it so far south and so far north, and you can't go beyond that.
Right. Well, I pulled up here that 240 on the screen.
Oh,
this
yeah.
is what gets me, the Luna Lima, whereas its furthest southern point, and I don't know if the right is the south or the north, but let's just assume this is the south on the right. The moon in its 28 days will get to its most southern point, and then while you can still see it before it's done, it'll be at its most northern point. Now, it doesn't necessarily, as you can see here on the right, let's just say that's where, well, I don't know where it would start here. I guess it would start on the second one, because that's the first crescent we can see. It's not at its furthest southern point, but within 5-6 days it is. And then it races the other way. And the point I want to make is that Sea of Crisis, when you can see it, which is most of the cycle, what they're saying is the Sea of Crisis rotates because of how far south or north it is when it rises. That's BS, because me and Mike Ball have noticed that where that Sea of Crisis is first identified, and it's either generally 5 minutes to 12 o'clock at 12 o'clock or 5 minutes after. Sometimes it's 10 minutes of, and sometimes at the other extreme it's 10 minutes after. But wherever that is, it's there for the entire cycle of the moon, as long as you can see that Sea of Crisis. It doesn't change, even though the moon is swinging wildly from south to north. So their excuse, because if you guys will notice, this moon, I think this moon was at 5 of, is where the Sea of Crisis is. It'll be at 5 of the entire cycle. The next moon might come up at exactly 12 noon, 10 after, 5 after, 10 of, who knows? But wherever it does come, it will be that way for the entire cycle. And their excuse that, well, that's the Sea of Crisis changes because it's either further south this month or farther north next month, is BS, because it's further south and north every month. It goes through its entire swing, as this is shown here, 28 days of the cycle. And with our photography, we can always see the Sea of Crisis because we overexpose it, even when you can't see it, and it doesn't change. So this field rotation is knocked out with that right there.
Yeah, field rotation is BS completely. And then they take their airplane, flying overhead, and you're standing right under it. Well, the natural thing to do is when it passes directly over your head, you spin your body and your camera to get it. And they say, "Wow, look at it! The nose has changed direction." Well, yeah, I understand what they're trying to say about this field rotation, but that ain't it. If you lay on your back and film the same airplane flying overhead, it goes straight, and we all know it goes straight. But
right.
I mean, their explanation, they're grasping at straws because they don't have anything else. But I think this you can't have field rotation without an arc. You could have everything move straight across, but if you have to be on an arc filming it, and half the month you would be on a reversed arc, which would make everything, even the constellations, rotate reverse. And they never mention that.
Mike Ball's got a question for you, for both you, Steve and Ron. Do you see the Sea of Crisis in the same position every night, rise in the same spot each night? Or have you noticed?
No, actually, I hadn't noticed if it's in the same spot.
I'm not positive, but I don't know. I couldn't possibly see the Sea of Crisis in the same location. But, that's something I have to confirm. I'm not sure.
Yeah, well, what I mean is, with each cycle of the moon, when you can first see the Sea of Crisis, notice where it is.
Right.
And you'll notice it'll stay that way for the entire 28-day cycle. And then the next cycle, all of a sudden it's in a different spot, and it stays in that different spot for the entire cycle once again.
That's right, at moonrise.
Right.
Yeah. I have to go back through some of my pictures and look.
Well, here it's for the entire half of the night, because, like I said, it doesn't rotate at all. How about in Florida? Does it rotate at all the first half of the night? It does.
Yeah.
Wow.
It depends on where it is in the sky. Yeah, I get a lot of rotation. Some nights I've got a video I can pull up real quick and show a little time lapse I did. It was I did this in November of 2018, but I took a picture every 10 minutes from 3 p.m. to 10:30 p.m.
Okay, and this is before you reach the zenith.
Yeah, I have to look back at that day. I think this was at moon. I started at moonrise, and moon rose at 3 p.m. that day. If I'm not mistaken, I have to go look it up on Mooncalc or something real quick. But
I hate to keep harping on the same thing, but I just find it fascinating that here in the Phoenix area for the first half of the night, we get no rotation whatsoever, none. That Sea of Crisis, if it started at 12 noon, it's going to be there until it hits the zenith. Then it'll start rotating. And then you in Florida, which is, I don't know your exact latitude, but you're not too far off of mine. I'm at 33.
Yeah.
I can see Steve maybe having some difference, not that much, considering it's supposed to be 238,000 miles away where he is. But I'm telling you, we get no rotation whatsoever here. The first half of the night.
Wow. Let me look this up real quick.
If you were filming a full moon, I have seen quite a few times where the full moon will be stationary for quite a ways on when it's rising. But if you were just filming full moons, the rest of them, like different phases, they move a lot at the from when it rises up until zenith.
Wow. Yeah, we definitely don't see that here. Maybe what we need to do is coordinate at the same day, taking pictures of the moon from the first half of the night for just a few hours at the 3 different locations.
Yeah, Ron and I were on the phone when we took pictures at the same time, and then we don't have to worry about trying to figure out the time differences and all that.
Right. And the other thing, just to bring it up, the other side will say, well, maybe your camera isn't on a tripod level and flat the whole time when you're taking a picture. That's what's causing you to have a tilt and somebody else not. And you don't need a camera for this. You can actually physically just go out and look at the Sea of Crisis. And you can tell if it's rotating or not. Go out a couple hours later and take a look at it again. You can tell if it's at the same position. Look at it as a clock.
Yeah.
The Sea of Crisis is your timepiece. And I'm telling you, each cycle it's different. And each cycle it does not rotate the first half of the night here.
I just looked it up. That video I've got, which showed a lot of rotation. The moon rose at 1:08 p.m. that day. I started filming it at 3, so it was just.
Yeah, it was definitely below azimuth. Yeah, definitely below azimuth.
Yeah, but I was showing quite a bit of rotation.
Interesting. Mike, you still here? Have you ever noticed rotation the first half of the night here in any of your time lapses that you've done? Here with me in the Phoenix area. There's always a 10-second delay, so it's probably just now getting to his ears. Mike is asking, got the wrong thing. He wants to know, does Ron and Steve observe same amount of pre-zenith rotation? Do you have the same amount of rotation, or have you noted that?
We haven't checked that out to see.
Okay. Mike says, just the last time we did the shadow experiment. We did have the, well, I won't go into that, but we're still doing we determined that, Mike determined that if you use a white ball, it's the same thing. We got the shadows pretty much match. The problem is we can't get behind that Doppler radar because it's fenced off. It's an Air Force area, and we can't get at the right angle. But we did determine that using a white ball will give you the exact same thing if you hold a white ball up in the air. And it gives you the exact same result as the Doppler radar. So we're going to be doing more with that. I think Mike wants to do a big white balloon that we can raise and lower type of deal. Mike says that was the first time he ever noticed pre-zenith rotation. To me, there's certain times in the cycle when things are different than other times. And I don't know why that is, but that's something that I think is just now starting to come on the radar screen. It's like when I'm convinced that if we can catch the moon early enough in the day when it's rising behind that Doppler radar or behind something, a white ball, we're going to see it because the sun doesn't arc over us. The moon must do an arc. It must turn to keep facing the sun. And here, for the most part, it doesn't for the first half. So I don't know. It's new stuff that we sort of stumbled upon that just doesn't make sense. And now that we're all talking, and you both, especially Ron, with his latitude is nearly mine, so that can't be the excuse. It's almost like we're seeing the moon through a different part of a projector or a lens, each one of us.
That could be. The personal atmospheric dome, that Jaron talked about on Globebusters, that could have a lot to do with it.
Well, and on the surface of the Earth, you might from the sun, you might well, I don't know. I was thinking you might get a different angle on the surface than you would up higher, which would make sense kind of a little bit. But if you're seeing exactly the same thing on the ball on the on the Doppler, then that wouldn't work out. Because as you move higher, you could see a different angle of the light.
Yeah, well, it's stuff that we'll just have to keep looking at. Where would you like to go next on the presentation, Steve?
Oh gosh, you're going to put that on me, so I have to
Yeah.
decide, huh?
Or Ron, either one.
I can show you a good rotation video I did, and this was pre-zenith.
Okay.
Share my screen, or it's on my YouTube channel.
Okay. Try to share your screen and see if I can see it.
Let's see. Getting all kind of warnings. Let's see.
Steve, if you could stop sharing your screen.
Oh, is it still sharing?
Yeah. Oh, actually, now it's not. I think. Let me see if I get this here. Is that it? Is that it, Ron?
Do you see a picture of the moon?
Yeah.
Okay. Yeah, that's
Let me make it larger. There you go. All right, it's on there.
All right, it's real short, but I started this at 3:10 p.m. I said the moon had been up for 2 hours, which usually takes me about 2 hours for it to clear the trees in my house. But here's some pictures I strung together. You can see the time. The time.
Wow. We definitely don't get that.
That's a good one.
Oh, we don't get that at all.
No, it's just I just zoomed in on a little bit.
Yeah. We get that after zenith, but not before.
Yeah, I get it. So I get it all day. And it depends on, I think I get a little more rotation the further south the moon is for some reason.
Interesting.
When it's further to the north, I don't get it as much.
So it doesn't work for you. That's the crisis is changing all day long.
Yeah. Some days it'll rise, see a crisis is near 12, and then I'll stop sharing. And then sometimes it'll only rotate maybe to 3 o'clock by the end of the day. Sometimes it does almost a 180 by the end of the day. So it's different. Yeah. It's different every time I do it.
Dale wants to know, let's see. He asked if they can see the shadow advance in one night. The shadow advance in one night. Oh, I see what you're saying. Does the shadow, can you tell if the shadow is actually growing or shrinking at the terminator line? I think that's what he's asking.
I've been wanting to film that for years now. Some people may not know that the moon only gets to 100% full on the day of a lunar eclipse. And you can tell the difference between a 100% and 99.9%. And when there's an eclipse in England, the last few eclipses have been in England, the moon has risen at 100% here and changed to 99.9, but it's been cloudy every time. I'm wanting to film that change from 100 to 99.9. I don't think anybody's ever done it, or vice versa. But I think we could film the actual phase change if we could have a clear sky when that's happening.
I haven't filmed it as it, all the way through when it moves, but I have looked at really zoomed in photos, and you can see after a day it has advanced some, because the shadows and the light on the craters and stuff will be different. So I think we are, it is a progressive thing. I don't know if it's actually a shadow, or if it's just burning up some of its fuel and retarding, I don't know.
Yeah.
But it looks like a shadow. I mean, I got to say that even the shadows on the in the craters, they look like shadows. So, the texture of what the moon is made of.
One of my bucket list items is to go to Longyearbyen, Norway. You can go up there, and the moon does not set for an entire 2 weeks every month. When the moon gets furthest north, it'll stay up.
Yeah.
It'll stay above the horizon for a week or 10 days every month. I want to go film.
Yeah, Pudsley Lovejoy has done some interesting calculations with the speed of the Earth at about where you want to go. The moon should appear to stand still, because remember their whole explanation of why the shadow of the eclipse, the Great American Eclipse, moved west to east was because the moon was actually moving faster than the Earth.
Yeah.
So.
Oh yeah.
Yeah, that's at a certain latitude, you go by the Earth speed is always calculated by the equator. So if you get up to about the Arctic Circle roughly, it should equal what the moon's retrograde or prograde, whatever it is, rotation is supposed to be according to the Earth, which would cause that shadow. And as you get north of that line, the moon should actually move the other way. It should actually go west to east, if you follow what I'm saying, because its speed will outspeed the Earth's spin at that point.
Mm-hmm.
But there should be a point where it's actually stationary.
Yeah.
If they want to use that stupid logic that they had to use for the eclipse to go the way it was.
Yeah.
Then you get to a point when on the Earth, and the other side will argue all day long about you don't understand angular momentum and different things like that, and they'll use things like that. But when you apply the exact same logic that they're using to this, you will get to the point where the moon would be absolutely stationary in the sky. You would just see the phases change. That's it. It would never move, because the Earth would be spinning at the exact same rate that that the moon is moving retrograde to the Earth, or prograde, whatever way it is, if you follow what I'm saying.
Mm-hmm.
And of course, that isn't going to happen. You're not going to get to a certain point, and all of a sudden the moon's moving a lot slower in the sky. Technically speaking, the sun should also move a lot slower in the sky too.
Yeah.
Because you're rotating slower. If the apparent rotation of the sun and moon or anything is caused by us rotating, then using angular momentum in mathematics, you get to a point where you're not rotating that fast anymore. And you get to, if you're actually on the pole, you're not rotating at all. But especially with the moon, because they have that supposed stupid backwards movement to create the eclipse shadow the way it works, because it doesn't make sense in the model otherwise, you would get a moon actually go prograde on you. You would actually have it rise in the west and set in the east at some point as you went north. I don't know, just throwing a lot of stuff out there.
I have another thing I want to bring up.
Sure.
I talked to a guy that was a soccer player from Chile one time, and I just so happened we were staying in the same place, and I said, what direction he was a ball earther completely. I didn't even understand what I was talking about, but I asked him, I said, what direction do you look at do you turn when you look at the moon? And he's in South America, Chile. He said he thought about it for a little bit, and he said, south. And I said, yeah, well, you should be looking north to see it. But so the other day, I'm going to try to hold this up. I went on MoonCalc. I thought, well, I'm going to actually look and see what MoonCalc says, because MoonCalc is fairly accurate. I mean, it's off sometimes a little bit, but from what I've seen and what I've heard people say, that it's fairly accurate on the azimuth and where the moon rises and sets. It might be off a few degrees, but it's not off a whole bunch of degrees. So see if you can see this or not. I'm going to try it. It may or may not work. Can you see that?
Yeah, let's see if I can make you come in larger. Let's see. Hold on a sec.
Okay.
Actually, what I'm going to do is I'm going to take me off.
There we go. Yeah, you can go away, Richard. That's okay. We got it. Teasing. Okay. See that all right? I lost the volume. I don't hear you. Anyway,
Yeah.
the,
Just keep going. Yeah, we can hear you.
the,
Good. Everything's good.
the blue is my location in North Bend, Oregon, right on the coast of the United States, on the West Coast. And mooncalc, the blue lines on the that would be on the compass there. It says is south, right? So Sydney, in Australia, you've got it's the red lines, and that's what mooncalc says. That's where it rises. The moon rises and sets from their vantage point. Not too much different than ours. And so we've got a problem. The reason people in Sydney, you see a reverse moon, almost a reverse mirror image of what we see in this, complete reversal. But I've always thought, and I know a lot of people do, that the moon would be right near the equator above, and we're both facing toward it. So one person the person in Australia be facing north, and the person in where I'm at, I'd be facing south. Well, that's not what mooncalc is telling me. It says we're both facing south. So how in the heck are we getting that reverse moon? Because you'd see exactly the same orientation of the moon, if you see what I mean. But if you're both looking toward each other and the moon was in the center, you could possibly see a reverse moon. Anyway, I thought I'd point that out.
Yeah, good point.
Now, I didn't pick any special day. I picked the day that I was on. That was on the 9th. And it just showed both of us look south.
But I assume theirs goes north during, like, when it's the highest or near highest. They look north and we still look south.
I don't know. I didn't try other dates, but if they always look south, then that looking at it like the moon was on the ceiling, it wouldn't work out. You wouldn't see a reversal. How it works, I don't know, but it won't work like that. Not if you both look south.
Yeah, they should never look south.
That's interesting, huh?
Well, it's just like the people in the north see like in the UK, they see the sunrise in the north in the summer.
Yeah, weird. Unless the land masses are in different location. A lot of stuff we don't know.
Yeah, when Daryl Marble went to Alaska, I was taking simultaneous pictures as him when he was doing the 24-hour sun. And when the moon rose here in Florida, I was looking due east and he was looking due north at the exact same time.
And where was he?
He was in Alaska.
Wow. Due north.
During the 24-hour sun. So, I still haven't been able to figure that out. But I was looking due east. And he was 1 or 2 degrees off due north. I explained that. They were both at the same sunrise at the exact same time.
Wow.
The mysteries never end.
Nope.
But what's really funny is when you take their own numbers and they don't work out. I mean, when you talk about like the angular size of Venus or even the moon, at the distance of the way they are, you shouldn't even be able to see them. I did a little deal on Venus and the sun, and Venus would be when it emerges from behind the sun. When either it goes behind the sun or emerges out the other side, because it does a full orbit around the sun, right? The sun is 93 million miles away, they say. Okay, it's said to be 1,300,000 times the size of the Earth. That's big. But in 93 million miles, it's reduced its angular size down to the size of the moon. So Venus is said to be a Earth-sized object. So if it's at its closest 24 million miles, how in the world do you even see a Earth-sized object that far? Okay, so then as it's going in its orbit, at some point, it's at the same distance as the sun. It's at 93 million miles. Now, the sun, being 1,300,000 times bigger than the Earth, has reduced down. How would you ever see an Earth-sized Earth-sized object at that distance? But then when that Venus goes behind the sun and emerges out the other side, now it's 93 million miles plus 800 and some thousand miles for the width of the sun, plus another 60 some thousand miles on the other side of the sun. Now it's 160,000 million miles away. So an Earth-sized object that you can see at that distance, that doesn't make sense.
No, a lot of it doesn't make sense to me. I mean, I don't even know how we can see the Sea of Crisis from 285,000 miles.
If the sun can reduce from 1 million times, let's just say, the size of the Earth in 93 million miles, if you just took one Earth and moved it the same distance away, there's no way you would see it. It would vanish way before you got there.
Yeah.
But, yeah. So anyway, that's you take their own numbers and you think about them, and it's just like, come on, what do you want me to believe next?
Probably what they're saying here. Where is it? Nibiru is based on heliocentric. Guys, we are never going to have Nibiru. Never, ever. All right, guys. Anybody? Well, do you have anything else you want to present, you guys?
No, that's good for today, I think.
Okay. How about I open it up for a few minutes of questions?
And I get more pictures of Venus from the south from anybody that could be.
Yeah. Yeah, we got 115 people now. So anybody that's knows anybody in the south, doesn't matter where you are, south of the equator, we're looking for pictures of Venus this cycle so we can compare angles.
And what direction you're basically looking, north or south?
Yeah. Yeah, the more information you give with it, the better the time of day, especially if you can give a UTC time. If you can use the theodolite app or some sort of compass app to show what direction it was. Just the more information, the better, but we will just take a date and the raw photograph. We're looking for the angle. So does anybody have any questions? No questions yet, but they're probably just now hearing me say it.
or we're just really good and answered everything.
I'm going to find that that area again that has the Venus pictures, the different angles. Where was that? That was pretty late on, I think. Maybe it wasn't. I want to show what we're looking for because there's a lot of people that are taking pictures, but it's showing. If I don't know even how to describe it, just shows like a blob. That's not what we're looking for. Like a translucent blob.
Yeah, you have to train a lot of people how to use a camera.
You're talking about the pictures of Venus?
Yeah, that you had from your location, from Dave Marsh, and from.
Oh, yeah. Let me see if I can find it. I think I know about where it was.
I think I'm getting close. Or I keep passing it over.
Right. It's at 304. You're talking about the
304.
different angles? See if that's the one.
There we go. Yes. Yeah, let me share. Go ahead and share this. So again, anybody that's watching, this is what we're looking for. Anybody that's south of the equator.
Now, my picture of Venus was a little blurry, and then Ron told me to set my camera to 500 and 1/500, and focus with the remote control, which gave me a lot better fine tuning. And then I started getting really clear pictures like the one that Dave has on from the UK.
Right.
They started coming out pretty good, because otherwise you can't really tell how big or how small it is, or the actual angle. Now, Dave had an interesting thing the other day. He posted that the angular size of Venus has enlarged, and I assume it's enlarged because the phase has been turning more and more toward a crescent, and the crescent one picture that he showed was way bigger. So I don't know what's up with that.
Yeah, that from that distance, it shouldn't be hardly any difference.
And that's what he was claiming, that it shouldn't do that.
You know what's weird here is you see Dave's picture. It looks like there's a dent in Venus in the, I don't know, just 6 o'clock straight down.
I've noticed that at times too.
And then your picture shows it too.
Yeah.
It's not as clear, but there it is. And then Florida, I can see the same area.
Florida's
The
got
left side.
a little bit of a dent there too.
Yeah.
And the whole thing, to me, a lot of times when I take pictures of it, it looks like it just kind of, it's not really like a ball. It's not the shadow. It looks distorted, put it that way.
Yeah.
Really distorted.
What was the settings was like 1/500 shutter speed or something like that?
Yeah, 1/500.
The way I usually do it is I put it in movie manual mode. If you have a P1000, put it in movie manual mode, and you can play with the shutter speed and see what looks the best. And then if you want to take a picture, apply those same settings to your picture, because for some reason, when you're taking a picture, it won't show you what it's going to look like before you snap it. You just see a big, overexposed blob until you snap the picture.
Right.
And I'll take pictures of it sometimes, and then I'll view it, and then if it's not quite right, I'll either advance my
Sure.
my aperture a little bit more or less. And
There was a question I thought. I'm going back and see if I can find it. I thought it was, Mike Ball says, if the moon follows the Sea of Crisis as is said, shouldn't it always rise at the top of the moon? Yeah, you would think so.
but
we know it changes.
that raises a really interesting question. You don't know what the top of the moon is, because it's never in the same location. It's always rotating. So which is the actual orientation of the moon that we should start out with?
Yeah, and trust me, here it's different every month. And Mike says set it at 500 watt. Can you clarify what that is? 1/500th focal length?
Shutter speed.
Shutter speed. Okay.
1/500th of a second.
Okay, gotcha.
That's a good starting point. You can go higher than that, depending on how bright it is. But the higher your shutter speed, of course, the less light it captures.
And you're going to be set at f8 probably. A couple times I've had to turn it down when it's still light outside. But.
Right. Man, that dent is intriguing me. Every picture I see, except for New Zealand, is just not clear enough. But that dent is on all three pictures. And it's supposed to be cloud covered, right? 100% cloud covered. So why is there a dent in it?
Well, Dave has taken a lot of pictures. He takes one almost every night, I think. And his are really clean. So you can see that on almost all of them. I've noticed it, but I didn't mention it because it's hard to really clarify what it is.
Well, you can't explain it in their model because Venus is supposed to be 100% covered with clouds.
Right.
So you wouldn't have a dent that would just stay there.
Maybe it doesn't have much gravitational pull in that area.
Yeah. Or maybe it's more in that one little area.
Right.
It's pulling the clouds down.
So the big question with what I've taken away from this for the last couple of months is the only time I've even looked at Venus. But my question is, how come Venus from my location, Venus has been static, hasn't rotated. It's the first picture I took and the last picture I've taken, month apart, they've all been at the same angle. The moon has rotated like a bandit all the time. And even when you see the Venus in the west, you only see it for about 3-4 hours. And it's never moved. The moon in the same area has rotated quite a little bit, all the way down to the horizon. Now, how come if we're looking through the same atmosphere and the same distortions and everything, and we're on the same curve and field rotation, then how come the moon rotates and Venus doesn't?
Have you noticed if the moon, when it's in the same part of the sky roughly as Venus, same height above the ground, is it the same angle as Venus?
When it was real close, I took a picture, and when it was setting, they were both almost at the same angle.
Okay.
But the problem with that one is I took theodolites. I took while I was out at the beach where I didn't have hills or anything in the way. So when I took a picture of the sun, I got the azimuth on that, and then I took a picture of Venus and the moon, and they were north of where the sun set, and their lighted side was facing north, but the sun was south of Venus and the moon. So that's interesting. Even it was a few hours later, but
yeah, sometimes most of the time it lines up, but sometimes when the moon sets, it's pointing opposite of where the sun set. Yeah, a lot of times. I mean,
I agree with you.
Yeah, you can.
We just have to catch it.
Yeah.
And you got to think about this. If the moon is constantly rotating, at some point in its path, it's going to aim directly at the sun. So I mean, if you rotate it, at some point it points at the sun, and the rest of the time it don't.
Yeah, interesting stuff. Do either one of you know how much longer Venus is an evening star? Or we're going to be able to compare this?
I have to look that up. I'm not
Yeah,
sure.
because I don't want to run out of time before we get somebody from the south to get us some decent shots.
We were talking about that last night. Ron and I were, that we need to look at that.
Yeah, so if anybody knows anybody in the south, please, let's get some Venus pictures so we can compare. You can send them to me, Rich at MrThriveAndSurvive.net, not .com, .net. And we can compare them and try to give us some information if you can, what direction you were facing and what time.
See Bob in the chat. Maybe he can get Eero to take some pictures for us.
And where's he located?
Eero's in
Chile.
South America somewhere.
South America?
Yeah.
Okay, that'd be perfect.
I think Argentina, isn't it, where he's at?
Yeah, he just said Argentina in the chat.
Yeah, if we could get some pictures from down there, that would help also.
I bet they don't flip.
Yeah, and if you can get a picture of the moon and find out if you're looking south, or if it rises or sets in the south of Argentina, that'd be interesting.
Yeah. All right, guys. I guess if nobody's got any other questions, we'll end it here. Thank you, Steve. Thank you, Ron, for both joining.
Thanks for having me.
And I really appreciate it. And you're the first one on these Sunday live streams. Next week, hoping to have Chris UK. He's been doing some, he's done flat earth stuff, but he's been doing fantastic stuff lately on the abuse of power that's been going on around the earth. And look forward to talking to him with that if he can make it next Sunday. If not, I guess I'll be back next Sunday. We'll talk about something. So again, thanks. Look up Steve on YouTube, Teeth of the Lamb. You have a channel also, Ron?
Yeah, it's just my name, Ron Hayberg.
Ron Hagberg. Okay, look up both those guys and share the love. And anyway, thank you both again for being
Yep.
here. Thanks for everybody in the audience. Great chat. I was keeping an eye on it the best I could. I know I probably missed a bunch of stuff, but anyway, hopefully this is a good time for everybody, these Sunday talks, and we'll do it at 12 noon for now. I think eventually we might go to 1 p.m. my time, Pacific right now. So anyway, God bless each and every one of you, and we'll be back soon. Take care, guys. Bye-bye.
All right.
Thank you.
Mhm.